and today I'm going to be presenting black holes. To get started. So what exactly is a black hole? So a black hole is consists of an area of concentrated dense mass, so it naturally does have lots and lots of gravitational force. And this all of this gravitational force is concentrated at the singularity. It has no surface and no thickness. So we don't exactly know what it is, we only know that it's there, and we don't know what it looks like. And today, only the most violent events can cause a black hole to emerge. Like, for example, a star merging, like two stars crashing into each other, or just one star collapsing into its final stage of death. And then it's possible to escape the black hole gravitational force as long as you are not in the event horizon. The event horizon is like the point of no return. And so then when you enter it, there's no way you can get back out into the rest of the universe. Not even light can get out of it. So good luck trying to get out there. So black holes actually also spin, and stars are actually just a bit bigger than a black hole. So, and they also spin. So when they start collapsing on themselves, they spin a lot quicker. And then when a big object becomes smaller, it spins faster. And then when a black hole collapses from a giant star into a tiny black hole, it can spin even thousands of times faster than the star before. A process called angular momentum makes the object not want to stop once it started spinning. And the black hole is so strong with its gravitational force, it is kind of literally dragging space with it. So this creates a region called the ergosphere. In there, everything is being thrown around. If you want to stand still, you have to stay faster than the speed of light. It is possible to get inside and get back out, but then if you get in, you'll probably exit out here without using literally anything. So then also the concentrated mass of a singularity won't exactly work with a spinning black hole. So then it spins so quickly that the singularity is thrown around and around and around the same spot, and it's more like into a sort of ringularity, which also has a thickness of 0. But then, if 1 trillionth of a second later, the singularity is here. Another trillionth of a second later, it's here. So then it spins really quickly. So it's kind of like the mass is concentrated everywhere around this round. So how do you classify black holes? So right now we've classified them as primordial black holes, are tiny, tiny black holes that may even be literally older than atoms. So they might even exist near the Big Bang. Any area with a bit more mass than its surroundings can just collapse into this tiny black hole. These primordial black holes can just having the size of a coin could be the mass of Earth. So a black hole the size of a coin could be orbiting the sun because that could have this mass of Earth. And then these things are very, very, very small. So we aren't even sure they exist. If they do exist, they might even be the mysterious dark matter that is holding galaxies together, because black holes are just so big that they sometimes look like the sun in the galaxy that binds everything into an orbit. But then this is misobserved because the star makes up literally almost all of the mass of its solar system. So, but black holes only make up a teensy bit part a very small part of the mass in their galaxy in reality. So it must be dark matter which is actually holding them together. Otherwise, it's the planets are just gonna float away. The solar systems are just gonna drift apart. And then there's this normal sized black hole that we know for sure exists, are called stellar black holes. They can go all the way up to 150 solar masses. And then there is a big gap in scale. The supermassive black holes are 2.5 billion solar masses. They are millions of times bigger than the stellar black holes, but there's nothing in between the biggest stellar black hole and the smallest supermassive black hole. This is a supermassive black hole, and this is stellar black holes. The universe is not even old enough for explaining the existence of these black holes by merging and eating stars. Like black holes can merge with each other to create bigger ones, and it can also just eat stars. Like there's a big blue giant here, and most of its matter just starts flowing down into a drain, and the drain is the black hole, and it just keeps enveloping matter. So where does these supermassive black holes come from? To explain the existence of these huge black holes, we might need to know the biggest stars who ever existed. Quasi-stars. Quasi-stars are really massive stars. So before in the early forming universe, a quasi-star might form and have some of its core already collapsing on itself to form a tiny black hole while the star was still forming. So then gravity would compress all the mass, and then the matter would, some of it would fall into the black hole. And then this matter is so hot that the radioactive pressure was keeping the star steady. That gave the black hole all it needed to grow at very high speed. So then these fully wood black holes can actually be the seeds for supermassive black holes or even ultramassive black holes. These black holes are just pretty much the same thing as supermassive black holes. They're just huge that they literally have their own name. They're just bigger. Thank you for listening to this presentation.